Hey, my name's Tyler. I'm the owner of the Discord server and the one helping you folks out. I'm going to go over first and follow sets now. Starting off with the first set is attempting to find the set of the first available terminals of a given non-terminal. So in defining those, if we look at this simple grammar here, our non-terminals are our function calls on the left and our terminals are on the right, meaning the ones that are not function calls. So when we're defining grammar as simple letters, what we're looking at in terms of uppercase is a non-terminal and lowercase is a terminal, including epsilon. So our definition for a non-terminal, we have a function call which has definitions. For example, over here, B is a non-terminal and it has one definition of terminal B. And for this definition of non-terminal A, we have two definitions denoted by this OR symbol, that we have a terminal A as a definition, or we have a terminal epsilon as a definition. And a terminal definition, all it states is that a token cannot be further defined. So in this case, with the lowercase letters and epsilon, we can't define them any further. They are the base case of the recursive parser. So if we attempt to find the first sets of our non-terminals, we're dealing with a top-down recursive parser, and you'll encounter this in the project. What you'll want to do with first sets is start with the lowest in the grammar order. In finding our first sets, we have two options. We have the first of a terminal, or we have the first of a non-terminal. If we're dealing with a terminal, as we are in definition B, it's simply the set of the terminal. So we could define first of B as the first of our terminal B, which is simply the set of B. And our first set for B is done. If we look at the first of A, very similar situation, but we've got two options here. So we would have the first of terminal A, and because we're using set theory, we would union it with the first of epsilon, and the union between two sets is simply the combination of all elements without duplicates. So we do not have multiple A's in a set, for example. So we would have A and epsilon as our first set for A, and that would be finished. Moving on to the first of S, we have the first of a non-terminal, and according to our definition up here, we would have the non-terminal minus epsilon as our return type. So if we're finding the first of A, we'll notice we're finding the first of a non-terminal. If we begin to build our set on the side here, our first of A would return the set of the non-terminal minus epsilon. So in this case, we would just have A being passed in, and A would almost be completed. But because our non-terminal can derive epsilon, we would also have to find the first of the next character. Because in our original grammar, where S is our starting grammar, if this non-terminal A can derive epsilon, it's essentially the same thing as having simply the empty string here. And if the empty string is here, then we haven't reached a terminal yet. So it's effectively the same thing as having S go directly to B. This is a possible pathway, so we have to include it. So if A derives epsilon, we have to find the first of the next character. So the first of B, as we have defined down there, is simply the terminal B, and we would include it. Our first sets are now done for this given grammar. The reason we would not include epsilon in this definition is simply because to have a non-terminal completely derive epsilon, you have to have a grammar rule specifically for it, or any non-terminals that you have as a definition for your rule have to completely be able to derive epsilon as well. So S would be able to derive epsilon if A derived epsilon and B derived epsilon. So because B does not derive epsilon, epsilon is not a possible pathway for S, and it is not included in the first set. Moving on to this second example, starting at the bottom, we have the first of D, which would simply be the first of a terminal, terminal D, which is the set of D. The first of C, we have two options. We have the first of a terminal, so we have the first of terminal B. We add that to our set, and we would union it with our other option for C, which is BA. So we would union that with the first of non-terminal B, which we do not have defined yet. So what I'm going to do is recurse back to this and find the first of B first. So the first of B, we have two options. We have the first of a terminal, which is terminal B, union with the first of epsilon, which would derive the set B and epsilon as our possible tokens, which would derive B and epsilon as our possible terminals. Recursing back over here now, we now have the definition for the first of B, so we would return this B, which already exists in the set, and we don't have duplicates, so that would not be added in. And the first of a non-terminal returns the set of all terminals except for epsilon, so we would not include epsilon in this definition. However, because the first of b can derive epsilon, if the first of a non-terminal derives epsilon, we have to find the first of the next character. So in this case, we would find the first of terminal A. So we would union that with the first of terminal A, add that to our set, and first of C would now be complete. First of A, we have the definition of terminal A, so we add that in as an option. We union that with the first of our next definition, which is CB, so our first of C. If we begin to build our set, we would have A. In terms of the first of C, we have A and B. We already have A in our set, so we would add B, and this definition would be complete for the middle option for A. To finalize the first of A, we would need to union it with the last definition, which is the first of another terminal, or just E, which would add terminal E to our definition. Finally, with the first of S, we have two definitions. To find the first definition, we would find the first of A, which if we begin to build our set, would be the set of A minus epsilon. There is no epsilon, so we simply add A, B, and E as our options. And because A cannot derive epsilon, we do not need to look further into our option for S. If A were able to derive epsilon, then we would have to look at the first of D. And if the first of D, maybe D is able to derive epsilon, then we skip past that one as well and move on to B. And if B derives epsilon, in this case it actually does, then we would move on to the first of C. So you continue to iterate through your given option until you find a terminal, or until everything is epsilon. Only when everything is epsilon can you derive epsilon. In this case, we can't, so we do not add it to the list. And in our second set, we simply have the first of B, so we add that into our work. We have the first of terminal B, it's already in the set, and our definition is now complete. Moving on to this final example. This is actually the exact same one from Adam Dupe's lectures, so if you'd like multiple perspectives on the same problem, go ahead and check that out. To begin, we start at the bottom with first sets. So the first of D, we have two options. We find the first of a terminal for our first definition. First of D, we union that with the first of our second option, which is epsilon, and we create the set D, comma, epsilon. First of C, very similar circumstance. We find the first of a terminal for our first definition, and we union that with the first of epsilon for our second one, and we create the set C, comma, epsilon. On to the first of B, only one definition, and that's a terminal. We find the first of that terminal, and we create the set B. On the first of A, we have two definitions. To begin with the first, we would find the first of C, which if we begin to build our set, the first of C is C and epsilon, but if we're finding the first of a non-terminal, we return that set without epsilon. So we would simply add C to our list. Because C can derive epsilon, though, we have to check the first of the next character. So we would find the first of D as well. First of D down here, we have D and epsilon. We return D, not epsilon, because we do not return epsilon. And in this definition, where C and D can both derive epsilon, not because we're returning epsilon from the first of C call or the first of D call, but because in the first of A, we can use the CD definition to derive two epsilons in a row, we now have a definition for A where we do not have a terminal. And as such, we would add epsilon to the list. In our second definition, we would then have the first of a terminal A, and we add that into our set, ending with that. For the first of S, we would take the first of our non-terminal A, which is equal to the set A, C, and D minus epsilon, first of A. Because A can derive epsilon, we would have to union it with the first of the next character, in this case, the first of B, which the first of B is just the set B, so we would add B into our list and be complete. The first of S cannot derive epsilon because in order to derive epsilon, in this case, A, B, C, and D would all have to be able to derive epsilon. And we can notice in this problem that even though A cannot derive epsilon directly as a given rule, it can use another rule, which are both function calls, to derive epsilon. This is very similar if we were to define an int. If we define int variable is equal to 0, in this case, this is very similar. Our variable is our non-terminal where it has a definition. It's equal to 0. That's the definition of this variable. That's the value that it holds. And so our 0 in this case would be our terminal, which is our base value that cannot be broken down any further. So we now have first sets for 3 separate problems of varying degrees of difficulty. In terms of work, there's multiple ways of showing your work. You could take my approach where you have the individual calls which are then unioned together, or you could show an iteration table in which you show one step of perhaps showing all of the first of the terminals, and then having a table where you have the first of the non-terminals, and then unioning those together.